So in this video, we're going to be discussing the second section of the book, section 1.2. Now in section 1.2, we're going to discuss a little bit more about graphs, and we're also going to specifically be able to determine whether or not the graph of an equation has any symmetry, and we're going to do that algebraically. The second main idea in this section is I want you to be able to graph circles from equations and find equations of circles given a graph. So before we get into either of those, I want to first talk a little bit about some equations. Specifically, what I would like to do is determine if the following points are on the graph or lie on the graph of the equation y equals 10x minus 7. And the 2 points are, let me just double check here, 213, we'll call this part A. Part B is -1, -3. Now keep in mind the first number is x, the second number is y. So in order to check, what we would do is just plug those in. So I'm going to plug 13 in for y, and I'm going to plug 2 in for x, which means I'm really double checking. 10 times 2 is 20. 20 minus 7 is definitely 13, so that works. For the other one, we're going to plug -3 in for y, -1 in for x. So I end up with 10 times -1 is -10, minus 7 does not work, so this is not true. So that means that we can conclude that 213 is actually on the graph. Okay, so I wanted to do this first just to make sure we're all on the same page when we plug in and when we're checking points, because that's going to come up when we talk more about symmetry. So let's talk about symmetry now. First of all, I want to discuss what it is. And to do that, we're going to look at 3 examples. And in order to do these examples, we're actually going to look at equations. So the first one is going to be this equation, y equals 2x squared plus 3. And I'm going to show you a graph. Now, I also want to use this as an opportunity to show you how the Desmos graphing calculator might work. So I'm going to switch over to our Canvas course. And on the left-hand side here, you should see a button called Graphing Calculator. I'm going to click on that, open that in a new tab. So if you'd like to follow along, this is where you could do it. The equation was y equals 2x. I'm going to hit this button to the right of x that says a squared to get a squared up there. And then I need plus 3. So there is the graph. I'm going to use my finger to kind of drag that around. Y equals 2x squared plus 3. So if we're looking at this graph, if we take a look at the y-axis, you'll notice that the graph could basically fold around the y-axis and it would end up on top of itself. So let's go ahead and go back into our notes now. I need my x, I need my y. So what I'm talking about here is if I kind of just rotated this around, around the y-axis, or you can think about it as folding over the y-axis, or if there was a mirror on the y-axis, the graph would stay the same. In this case, we say the graph is symmetric on the y-axis. So this is a key point to make here, symmetric on the y-axis. The next example I'm going to look at is going to look a little bit strange because it doesn't just have y equals to start with. I'm going to write my equation like this, which is totally fine. X squared plus y cubed equals -1. That's an equation. Now, Desmos is great because you don't just have to always put in y equals. You could also do, let's go ahead and remove this one. So I'm just hitting backspace. So I can actually type this in exactly, x squared plus y. Now, do you see next to the a to the power of 2, there's an a to the power of b? I'm going to hit the a to the power of b button, and I'm going to put a 3 there. Now, if I start typing again, it goes back down, which is nice. If it didn't, you can use the arrows all the way to the right underneath the functions button, and you can move your cursor along wherever you need it to go. But we said this equals -1. So in this case, the graph looks to me like it has some symmetry around the y-axis again. So we're going to go ahead and say I think it kind of looked like that. And so this is again symmetry on the y-axis. Okay, so now you kind of are getting the hang of things. We've done 2 symmetries on the y-axis. Let's change up our formulas here and let's do a couple of other symmetries. So I'm going to look at now y equals, let's say, the cube root of x. So going back to my Desmos graphing calculator, let's do y equals, now cube root is a little bit harder to get to. The way I do it is I click on the functions button. At the top you see trig, stats, distance, I think that's distance, and then misc for miscellaneous. You're going to click on the misc button. And down where it says, it has a little n on top of the root, that stands for nth root, meaning it can be whatever you like. I would like it to be 3. So once again, I hit the functions button and I click the one that has the n with the square root looking symbol, the root symbol. So once that was in there, I typed the 3, and now underneath I'm going to put x. So this one, I'm going to actually move both my fingers away from each other to zoom in. If you're not sure how to do this, I can show you in class. And take a look at this sort of weird looking graph. Let's go ahead and copy this one into our notes. So it looked like it was something along the lines of this. Since it's a sketch, we can afford to be a little bit not careful. So it looked kind of something like that. I won't put the scale in. Now notice if I rotate this, if I rotate that over there and that over there, it would actually end up in the exact same spot. You can try spinning your iPad around and it should look the exact same. And this one we say is symmetric on the origin. What this means is that it can rotate 180 degrees and end up back where it started. So we now have 2 symmetries. We have origin symmetry and we have y-axis symmetry. For the last one, we're going to create something that isn't actually a function. So I'm going to use absolute value of y equals x here. Let's go ahead and graph this one. Now the absolute value button, if you look on the bottom left of your keyboard where it says ABC, right above that you should see the absolute value of A. You can click on that. I'm going to type in Y, and then I'm going to click on the absolute value button again. And then I need this to equal X. So Desmos is nice because it can even graph things, graph equations that are not actually functions, whereas your graphing calculator cannot. So in this case, we see kind of a sideways V, I guess you could call it. So let's go ahead and let's graph this. This is the last one we'll do. And what you might guess at this point, we covered symmetry on the y-axis. Now we're going to cover symmetry on the x-axis. Notice that if I reflect this top portion to the bottom and vice versa, if I reflect over the x-axis, I will end up with the same function. So therefore this is symmetric on the y-axis or the x-axis. Okay, now the next question is really, why are we doing this? So it's first of all good to just be able to have some words for graphs. So it's good to be able to describe graphs however you can. Throughout your career in math, you'll have to do this. You'll have to figure out patterns and figure out how different graphs work. Additionally, we're going to be using this for some algebraic work. And this is really the key part of why I do it. We're going to set some problems up here which deal with equation manipulation, which is just good practice to have in a math class anyways. And going forward into your calculus classes, you're going to have to deal with some pretty heavy-duty algebraic equations. So this is a good chance to make use of some structure and some patterns and just kind of get our hands dirty with some algebraic equations. So I'm going to stop this video here because it's getting a bit long. And in the next one, we're actually going to go into the algebraic side of symmetry.